So we're going to be getting into scientific notation. We kind of covered, so we did the exponent unit last semester, and scientific notation usually just goes hand in hand with it because it is an exponent or an exponential way of writing a number, but they had us splitting it up to this semester. So we're going to cover it. It's a really quick unit, guys. In fact, you're going to be testing on it next week on Friday. Yeah. Yeah, you're supposed to be leaving now. Make sure you look for the video. It'll be loaded into Google Classroom because you need to keep up with the assignment, okay? So you're going to be testing on this next week on Friday. Also next week, Monday and Tuesday, it's going to be the screener testing again, which is that iReady testing. So you've got that for 2 days. So really we're going to have today and tomorrow, and then Wednesday, Thursday, Friday. Yeah, you bring everything with you. All right, so scientific notation, it's just a smaller or shorthand method for writing a really, really, really long number. Not a large number, a long number. It could be a small number with lots of values behind it, behind the decimal. Or it could be a really large number with lots and lots of zeros. So it's just a very quick, kind of like the lazy way of writing these longhand numbers. So what's important to make sure you understand, it is a decimal value that's greater than or equal to 1. So it could be 1.0, or it could be 1.2, it could be 7.8, it could be 9.7, but it has to be less than 10. It cannot be equal to 10. So the best way to think about it is you're creating a decimal value that has only one number in front of the decimal. Only one number in front of the decimal. If you have more than one number to the left-hand side of the decimal, then it's not correctly written in scientific notation. So once you get a number or a value that is, a number, decimal, and then something else, it's going to be multiplied by what we call the base 10. Okay, and the base 10 has a power, and that power is going to indicate whether this is a large number or a small number. So your exponent of base 10, like I said, it's going to indicate how you would write your number, the format that you write your number. If it is a greater number, a larger number, then you're going to write it meaning greater than 10. If it's greater than 10, then you're dealing with a positive exponent. This will be a positive exponent. If your number value in standard form is greater than 10, then that means that you are dealing with a positive exponent. If your number value, your standard form of your number happens to be smaller than 1, not smaller than 10, but smaller than 1, then you're dealing with a negative exponent for your base 10. Okay, so this is very important to understand. And your exponent is going to act as a direction for how you move your decimal. When you're going from scientific notation into standard form, your exponent will be the GPS. It's going to tell you whether you're moving your decimals to the left or if you're moving your decimals to the right. Obviously, if it's a positive exponent, what direction do positives go? To the right, and the negatives go to the left. Okay, so if you want to put that down, you can. That for positive exponents, you're going to be moving the decimal to the right. With a negative exponent, you're going to move your decimal to the left when you are translating scientific notation to standard form. So here, these are examples of scientific notation. We have 2.08 times 10 to the 6th. We have 7.8 times 10 to the negative 4th. 5.7 times 10 to the negative 3rd, and 9.742 times 10 to the 12th. Notice that every one of these decimal values only has a single number to the left-hand side of the decimal, right? It's creating a number that's greater than or equal to 1, but they're all less than 10. Every one of these decimal values is less than 10, okay? So when we are translating these into scientific notation, or into standard form, we're going to take a look at what the exponent is. So the exponent is going to give us that direction. So right now, this exponent right here happens to be a positive. Since this is a positive, then that means that we're going to move 6 units to the right. Because we're dealing with a positive 6 for our exponent, we're going to move our decimal 6 units to the right. So when I'm starting with 2.08, I need to move that decimal 6 units to the right. So if I move it one time, that puts it at 20.8. If I move it a second time, I'm now at 208. But now I don't have anything to move past. So what do I have to add here? Zeros. You add some zeros. It doesn't matter how many zeros you add. I can add as many as I want. I'm just going to add a whole bunch, and then I'm going to continue moving. So I've moved once, twice, 3, 4, 5, 6 times. This is where my new decimal is going to go. So that means that my scientific notation is translated into the following standard value: 2080000. That means it's 2,080,000. So 2,080,000 can also be written as 2.08 times 10 to the 6th. Okay, that's just, again, indicating the direction that we are moving our decimal to rewrite our number into that standard form. If we take a look at problem number 2, the exponent happens to be a negative 4. And since it's a negative, what direction are we going to move? To the left. And we're going to go ahead and move 4 units to the left. We're going to move 4 units to the left. So when I write this out, I've got 7.8. I need to move my decimal to the left 4 times. So I'm going to go 1 time. If I go a second time, I need to add a 0 here. If I go a third time, I need to add a 0. And then a 4th time, I need to add a 0. And it's okay for me to have a 0 in the front of it as well. Okay, so my new decimal is going to go located right here. So my value is 0.00078. I know my pen is running out of ink. I'll rewrite. 0.00078. Okay, there's our final answer. I want you guys to go ahead and do problem 3 and 4 on your own, please. All right, who can tell me what did you get for problem number 3? 5.7 times 10 to the negative third. What is that going to look like? Alex? Where's your decimal? Yeah, so you have to say 0.0057 or 0.0057. Okay, so again, we're dealing with that negative exponent here. Since that is a negative exponent, that means that we are going to go ahead and translate it 3 units to the left. So when we're starting with our standard value of 5.7, or sorry, our scientific value of 5.7, we're moving 3 units backwards. So we're going to go 1, 2, 3, place our new decimal there. We're going to add in our zeros as placeholders. You can do 1 in the front as well. It's perfectly fine. So your value should be 0.0057. Okay. What about number 4? Bridget? Okay, so So let's take a look. So we've got a positive exponent of 12, right? Got our positive exponent of 12, so that means we're going to go 12 units to the right. So start with our scientific value, which was 9.742, and we're going to move 12 units to the right. So 1, 2, 3, and then 4, 5, 6. I'm going to have to add a bunch of zeros. 7, 8, 9. And then 10, 11, 12. Okay, so when we write it out, we get 9, 7, 4, 2, 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay, so 9,742,000,000,000. Okay. So now what's important for you to understand, our large numbers yield positive exponents when we translate them into scientific notation. Our small numbers, meaning numbers that are smaller than 1, are going to yield that negative exponent. So when we're working from standard to scientific, you're going to work in the reverse. In order for us to be able to create this as a scientific notation, we need to identify what is our decimal value going to be, and what is that going to translate to as an exponent when we maneuver our decimal to that location. Okay, so for the first one, this is a large number, right? Large number means that it's going to equal a positive exponent. A large number is going to become a positive exponent. That's important for us to understand. Now, our decimal value must be greater than or equal to 1, but less than 10. Where do I need to place my decimal in order to create a number that is greater than or equal to 1, but less than 10? Between what two numbers am I going to place my decimal? Maya?
5 and 2.
Between the 5 and the 2. Okay, my decimal is going to need to go here. So I need to create a 5.23. I don't have to create all those zeros. I know I'm going to be multiplying it by a base of 10. And now I got to figure out what the exponent is. So originally, my decimal was in the back over here. So I just got to count how many times or how many spots did I have to move in order to get to my new location. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 spots. Okay, so it should be 10 to the 13th power. 5.23 times 10 to the 13th power. For problem number 2, this is a small number. It's less than 1. So it's a small number. That means we're going to be dealing with a negative exponent. We're going to deal with a negative exponent because we're dealing with a small number, a value that is less than 1. Where do I need to place my decimal in order to create a value that's greater than or equal to 1, but less than 10? Between what two numbers? Bridget? Between the 3 and the 7. So we're going to place our decimal here. So this is going to become 3.7. Now, originally, my decimal is located right here. So I need to count how much I move in order to get to my new placement. 1, 2, 3, 4, 5, 6 spots. So is it 10 to the 6th power? No. Why not? Because it should be negative. This was a small number. It should be a negative 6. Should be a negative 6. Okay? Go ahead and do 3 and 4 on your own, please. All right, let's go ahead and go over this one for problem number 3. For problem number 3, you can tell me what it's going to be. Armando?
7.12 times 10 negative 11.
Okay, so let's take a look. 7.12 times 10 to the negative 11th power. So again, this is a small value. Our decimal needs to go between the 7 and the 1. So we're going to create a 7.12. We know it's going to be times the base 10. And then when we calculate it, we're moving 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 spots. But because it is a small number to begin with, it's a negative 11. What about for problem number 4? Ray, what did you get for problem number 4?
I got 15.24 times 10 to the power of 10.
Okay, so 15.24 times 10 to the power of 10. What mistake did Ray make? Alex? She made the base value bigger than 10, right? Remember, scientific notation means your decimal value is always going to be greater than or equal to 1, but it has to be less than 10. 15 is not less than 10. So where do you need to place your decimal value between? Where should you place it between, Ray? In between the 1 and the 5, right? Should go in between the 1 and the 5. So this should be 1.524. Now let's go ahead and see our original decimal. Our original decimal was in the back. So we would move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? So it should be times 10 to the positive 11 power because this was a large number. Right? Any questions so far? All right, let's go ahead and go on. So go ahead and turn your paper over to the back. Okay, for computation, you're going to need your calculator at this time. So if you don't have a calculator at your desk, please go ahead and grab one. So you guys are lucky. You guys get to use your calculators for this. In the past, they used to have this be a no calculator unit, and you actually had to know how to work the problems out, where you'd have to go, okay, I'm going to multiply my decimal values together, and then I'm going to multiply using my exponent rules with my base 10s, and then if I create a number that is not in scientific notation, then I'm going to have to reevaluate it and rewrite it into scientific notation. It was a longer process. Okay, or same thing for addition and subtraction. With addition and subtraction, you had to have exponents that were the same. So if you had a value that wasn't in the same exponent, you had to manipulate one of them to become the same exponent, meaning you would either move your decimal to the right or to the left to change your exponent's value, and then you could add or subtract and then rewrite back into correct scientific notation. It's a long process. It's not difficult. I see Bridget going, sure. It's not difficult process, but your new AKS is just focusing more on, do you understand when to add, subtract, multiply, and divide when you get word problems. So we're just going to go over how to use our calculator with the basic ideas of them. Tomorrow you're going to be getting actual word problems where you have to figure out when do you multiply, add, subtract, divide. Okay, so for these, right now your calculators are in a standard mode. So if you hit the mode button, yours right now has the norm highlighted. You want to highlight scientific. So if I clear this and it looks like yours, this is what yours should look like right now, where the norm is highlighted. You want to go down one and to the right one, so it should be flashing over SCI, and then you want to hit enter. So now your calculator is in scientific notation mode. Okay, so again, you're going to hit the mode button. You're going to move your arrow down one to the right one and then hit enter so that your calculator is now in scientific notation mode. And then you're going to hit clear. I want you to practice. type in 842 and then 0, 0, 0, 0, 0, 0, 0, 0, 0. 842, 0, 0, 0, 0, 0, 0, 0, 0, 0. Should have 9 zeros there. And then hit enter. It's going to tell you what the scientific notation is. Okay? So you get 8.42 times 10 to the 11th power. It's going to go ahead and tell you what it is. If it gives you the correct spit out, then that means you're in scientific notation mode. And then all you have to do when you're actually working through these problems, you type them exactly as you see them. I implore to you, it is very important that you use parentheses or type it exactly as you see, especially when it comes to division. Okay, so we're going to skip number 1 for right now. I want you guys to go to number 2. Okay? What I want, my first two rows, I want you to type it in exactly as it is. Type a fraction, so hit the fraction bar, and then put 8.37 times 10 to the 8th on the top, 2.7 times 10 to the 3rd on the bottom. My second two rows, I want you to just type in 8.37 times 10 to the 8th, and then hit divide. No parentheses, nothing of the sort, just hit a divide symbol, and then 2.7 times 10, and then to the 3rd. Okay? First row and second row, you're going to type it like a fraction. Third and fourth row, you're going to type it just as I said. No parentheses, but type it as a division problem. Paris? What do you mean? Let me see it. It's on. Okay. Well, in those cases, always just hit on and clear at the same time. Okay? So there you go. All right. Somebody from the third row. Somebody from the third row. You should have typed in 8.37 times 10 to the 8th divided by 2.7 times 10 to the 3rd. Can somebody share with me what they got as their answer from the third row? So like Dylan or Abakar or Divya, Michael, somebody from that row. 3.1 times 10 to the 11th, okay? So when they typed it that way, they got 3.1 times 10 to the 11th, which is what I got to when I typed it in that way. Now, somebody from the second row that did the fraction version, what did you get? French-Zheng, what did you get? 3.1 times 10 to the 5th. Notice they're different. Those are different answers. Because of the fact that your calculator, when written like this, it follows the order of operations. So it did 8.37 times 10 to the 8th. Then it divided that by 2.7. Then it multiplied by 10 to the 3rd. Instead of multiplying these and then dividing. So there's a problem. You have to make sure that you are following the order of operations correctly, which in this format means you have to do the multiplication here first, multiplication here second, and then division at the end. Okay? It's very important that when you type these into your calculator, you type them exactly as they are seen. If there are parentheses, I would type the parentheses. It's not necessary all the time. Like for multiplication, number 1, all of this is multiplication, so the parentheses aren't going to make much of a difference. But get into the habit of putting those parentheses so that when you get to a problem like number 2 or number 4, number 8, things like that, you will have those parentheses placed and it will follow the correct order that is necessary. Okay? I want you guys to go ahead and do all of these problems on your own using the calculator. Let's see if you can use the calculator correctly. Now, if you just did what I did and hit the memory clear, that means you reset the mode, and you need to go back in and fix the scientific notation mode, okay? For problem number 1, you should have gotten 9.6 times 10 to the negative third. 9.6 times 10 to the negative third. For number 2, like we said, 3.1 times 10 to the fifth. You want to make sure that you write it exactly as you see it. For problem number 3, 1.504 times 10 to the seventh. 1.504 times 10 to the seventh. Number 4 is 9.929 times 10 to the fifth power. Easier to see. Okay, number 5, 7.839 times 10 to the sixth. Number 6 is 9.563 times 10 to the 11th. For number 7, 9.83 times 10 to the 8th. Number 8 is 4.4 times 10 to the third. Okay, again, very important that you have put those parentheses around the scientific notation in order to be able to get the correct value. Okay? All right, ordering. The last thing that we're going to talk about is putting scientific notation values in order. So when you are placing scientific notation values in order, it's important to understand that you first focus on the exponents. If all of the numbers are written in scientific notation, if all of them are correctly written in scientific notation, you first are going to focus on the exponents. So let me write that down. If all the numbers are correctly written in scientific notation, then the first thing that you're going to do is rank them by the exponent. You first rank it by the exponent. If they're not all correctly written in scientific notation, then just change the ones that aren't correct into scientific notation. You can easily just type it. Like I said before, like let's say that number or problem A wasn't 3.75 times 10 to the negative fifth. Let's say that they accidentally had it written as 37.5 times 10 to the negative 6. Then you would just type in what you've got, 37.5 times 10 to the negative 6, and hit enter, and it'll place it into the correct scientific notation for you. Okay? So if you see, hey, 37.5, that's not scientific notation, then type in what they wrote and hit enter. As long as you're in scientific mode, it will spit it out in scientific notation form. So 37.5 times 10 to the negative 6 is the exact same thing as 3.75 times 10 to the negative fifth. Same thing here. If I did 0.375 and then times 10 and to the negative fourth, it's also going to come out as 3.75 times 10 to the negative fifth. Okay? So if you notice that there is a value that's not in scientific notation, then type it into your calculator exactly as you see it, hit enter, and if you're in scientific mode, it'll tell you what it looks like in scientific notation, and then you can write that down. You want to compare those values in scientific notation form, because then you just go by the exponent to start with. Okay, if you've got So here we've got these exponents. We've got -5, -2, and -3. We want to go from least to greatest. So which one of those exponents happens to be the smallest? Which one is the smallest? -5. -5 happens to be the smallest exponent. And since they're all in scientific notation, because this is the smallest exponent, that means that this is the smallest number. Okay? So A is going to be my smallest value. I'm going to go ahead and put A down here at the bottom. Okay? Then we've got -2, -2, and -3. Well, which one of those is smaller? D, right? -3 is the second smallest. -3 happens to be the second smallest, so I'm going to put D. Now, both of these are -2 and -2. So once you get it down to where you've got identical exponents, if you have identical exponents, then you're going to compare the decimals. So if you have identical exponents, then you'll compare the decimals. These exponents are both -2. So that means I'm going to focus on 2.8 and 2.87. Which one is smaller, 2.8 or 2.87? 2.8. Okay, 2.8. 2.8 happens to be smaller than 2.87. So we're comparing those. So that means that B is smaller than C. And there's your order from least to greatest. Value A, value D, value B, value C. You compare in scientific notation mode. If they're all in scientific notation mode, you focus first on the exponents. Then if you have identical exponents, you focus on the decimal. Any questions? Okay, on Google Classroom, there are 5 IXL skills. On scientific notation, you've got a skill in which you are translating back and forth between scientific and standard. You have a skill in which you are comparing scientific notation. And then you've got a skill on addition, subtraction, a skill on multiplication, and a skill on division. Go ahead and get to what SMART score? 70 or higher. What's the cap off? 80. Don't accept anything past an 80, so don't go beyond that if you don't need to.